Tax money becomes budget for government projects. Are we overpaying? Well, let me introduce you to our project, Predicting Budget Variance in Philippine Government Procurement using Machine Learning. So let's meet our members. The Philippine government agencies struggle with unpredictable cost and schedule overruns in procurement projects. According to Famadico, there are evidences of significant and persistent budget overruns in public infrastructure projects. They now identified some of the factors such as underestimated scope, land acquisition delays, suspension of work, and price volatility. So what's the gap to address? Procurement officers make decisions based on estimation rather than evidence. There are no predictive tools that exist to flag high-risk contracts before bidding begins. So what do? We examined budget variance patterns across government procurement contracts in the Philippines using historical PhilGAPS data to identify hidden patterns. We leveraged CatBoost algorithm to classify contracts based on budget outcome behavior. Here's our project domain and our target users.
So, government procurement is the process kung paano yung mga Philippine agencies nag-acquire ng goods, services, and infrastructures. It's a cornerstone of public service delivery, but despite its importance, yung procurement process is highly vulnerable to budget variances caused by technical, market, and administrative factors. And pag nagkaroon ng budget deviations, it affects fiscal planning, disrupts timelines, and wastes taxpayers' funds. So, for the problem of the statement, we have 4 problems that we want to address. The first one is budget uncertainty. Projects often experience unpredictable cost overruns. The second, lack of predictive tools. Agencies don't have a data-driven tools to forecast budget variances before bidding. The third one is estimation-based decisions. Government rely on guesswork instead of evidence-based analysis. The fourth one is optimistic bias. Initial estimates frequently underestimate actual costs, so there are the gaps that we want to solve. So, for the objective of the study, we have 3 objectives. First is to identify which procurement features like region, entity type, and procurement modes are most linked to budget outcomes. The second is to determine which contract types and locations are most likely to go over or under budget. The third is to develop a classification model that predicts budget status using pre-bid features. So, pwede gamitin before pa ma-award yung contract. So, for scope and limitations, for scope, we use PhilGAPS data from Q1 to Q3 of 2025, awarded contracts only, with pre-bid features. For limitations, we have severe class imbalance. Our budget is only 0.01%. This model is trained on 2025 data only, and we did not include external factors like inflation or market price changes.
In recent years, machine learning has become widely used for making predictions across many domains, especially when working with structured data like government procurement records. Models, such as decision trees, regressions, and ensemble methods, are effective because they can uncover patterns that are not immediately visible in large datasets. This makes them valuable for procurement analysis, where identifying budget behavior early can help agencies allocate resources more efficiently and make evidence-based decisions. CatBoost stands out in the literature as one of the strongest algorithms for categorical tabular data. It avoids overfitting through ordered boosting, handles categorical features natively, and consistently performs competitively with XGBoost and Light GBM. This strength makes it a reliable choice for our study's goal of detecting subtle budget variance patterns, especially in a dataset with severe class imbalance.
So meron kaming 5 reasons bakit namin pinili si CatBoost as our main algorithm. One is it handles class imbalance well with its ordered boosting. So this is very crucial for us since we have identified in our dataset na merong sobrang imbalance. Next is nag-handle ito ng categorical features or native sa kanya to. So hindi na namin kailangan mag one-hot encode or turning categorical features into binary. 3, its tree-based structure captures non-linear relationship between features. Procurement outcome depend on complex combination of factors. 4th is yung prevents overfitting. So yung ordered boosting prevents overfitting and target leakage. So this ensures na hindi siya more on bias dun sa training dataset namin. Lastly, consistency CatBoost as a top performing on tabular data. Our data is from PhilGAPS Open Data Portal or the Philippine Government Electronic Procurement System, which is yung naging centralized ng mga procurement logs for publicity or for transparency for bidders and for the community. So, we have utilized the year 2025, Q1 to Q3 na procurement logs per activity. So, around 400,000 rows each quarter and 46 or columns yung nandun sa each quarter. So, around 1.2 million yung naging dataset. Pero hindi naman lahat is nagamit since meron naman mga procurement projects na hindi na-go through or na-cancel or na-close. So, we have only chosen yung mga awarded or yung mga na-go through. So, after cleaning, we have identified 423,556 na awarded na projects. So, ito yung magiging main dataset na gagamitin namin for machine learning. So, moving on naman tayo dito sa slide na target variable namin. So, here, sa pinaka-data science project namin is predicting budget variance. So, ang pinaka-tinitingnan namin is under, on, or over budget. So, nung tinignan naman yung dataset or ina-analyze namin, nagbigay kami ng conditions and we compared the contract amount to the approved budget para makuha yung mga status nila. As you can see, nung ina-analyze namin is from that 423,556 na data from our dataset na cleaned, more on awarded, is 88% is yung under budget, 11.9% is yung on budget, then sobrang imbalance and konti lang yung nag-over budget, which is 0.01. Ito yung pinaka naging basis ng budget variance namin. So, under, on, and over budget.
Our results show that region is the most influential factor in predicting budget outcomes, accounting for 15.3% of the model's total feature importance. This indicates that geographic market conditions, vendor availability, and regional pricing patterns strongly shape whether a contract ends up under, on, or over budget. When looking at contract types and locations, we found that civil works and goods projects are the most likely to finish under budget, while consulting services tend to fall on budget or exceed the approved amount. Regions 5, 10, and 2 perform consistently well with very few over budget cases, whereas Caraga and Region 7 show higher risks and therefore require closer monitoring. The analysis also suggests that public bidding generally leads to more stable budget outcomes compared to procurement modes like international competitive bidding. For overall performance, the CatBoost classifier reached 92.06% accuracy on the test dataset. It shows strong predictive ability, especially with high precision for the small number of over-budget cases, while recall for on-budget outcomes is lower due to class imbalance. The model performs very reliably. In terms of feature importance, the top contributors, which are region, business category, contract duration, organization type, and approved budget, make up over 60% of the model's decision-making. These findings highlight that regional conditions, contract characteristics, and organizational factors collectively play a major role in driving budget variance. To summarize, our CatBoost model achieved a strong performance with an overall accuracy of 92.06%, showing that it can reliably classify procurement contracts based on expected budget outcomes. The results highlight that region, business category, and organization type are the strongest predictors, which means that geographical and institutional factors heavily influence budget variance.
Here is our references. Thank you for watching.